The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
You feel some rumbling from below. No, it's not your tummy. It's low and ominous. You look up and see strange lights hanging above the ground. They look like shimmering balls of light hovering high up in the sky. Your throat goes dry and you gulp. That's what they call the earthquake lights. This phenomenon is poorly understood, but witnesses say they've seen it in different shapes and sizes. It could be in the form of light balls, sheet lightning, streamers, and a steady glow in the sky. Soon after, a strong earthquake follows. Scientists can't explain why those lights appear, and they don't always do either. Some believe that's a reaction of underground gases released into the atmosphere. Sure enough, an earthquake begins. But lucky you, it's not as strong as you expected. The ground is shaking, but you even manage to keep your balance. It stops as abruptly as it began, and you walk home. On the way home, you see a flash and hear a whip crack. Lightning has struck a lone tree near where you just stood. It's caught on fire, and there's a column of flames rising to the sky. Still no rain, and the pillar becomes taller and taller. Have you heard of such a thing as a fire tornado? These phenomena occur when the wind is caught in a circle close to the ground because of the difference in air pressure. Such mini tornadoes are usually easy to notice. Small rubble, dust, sand, and leaves rise into the air and start flying in rapid circles. But then, if there's a source of fire nearby, the funnel can catch it and blow it stronger, like bellows. The flames go round and round, reaching ever higher and eventually creating a swirling, blazing tower. Luckily, fire tornadoes are short-lived and don't normally cause much damage. But don't try to hide from the storm under that tree. You can find this unusual plant in Florida and in some parts of the Caribbean coast. Externally, it doesn't look special at all. A gray trunk, green leaves, and fruit similar to small apples. What you must remember is never to pluck these apples and never stand next to the tree, especially if it's raining. This is the manchineel tree, which is considered the most dangerous in the world. Its trunk, bark, branches, and fruit contain poisonous juice. One drop of this corrosive acidic liquid can harm your skin a lot. The tree can secrete this juice, and if you accidentally touch it, you risk burning your hand. When it rains, water droplets fall on the tree and mix with the poison. Water can also bounce off the bark and get on your skin. That's why you shouldn't stand nearby either. There are almost no other shrubs or mushrooms growing around. Animals avoid these trees, and people don't chop them and don't pluck the fruit. You can't make a bonfire from their branches. Burning wood emits poisonous smoke that can damage your eyes. Locals know this tree well, but tourists and travelers might accidentally get harmed. That's why most manchineel trees are marked with paint or have a warning sign. In western Venezuela, locals living close to the Catatumbo River aren't afraid of lightning because they see it almost every single night. It starts at around 7 o'clock and doesn't stop until dawn. The everlasting Catatumbo lightning did once stop for a few months, from January to March 2010. It was probably due to drought, or maybe the charge ran out. In 1991, a scientist suggested that the phenomenon happens because of cold and warm air currents meeting in the area. Another theory is that the lightning could be due to the presence of uranium in the bedrock. Not all lightning happens inside clouds. There's a rare phenomenon called a dirty thunderstorm. The lightning happens above a volcano. The most famous is in Japan. It erupts almost every day and spits black clouds high into the air. So it's super scary volcano clouds plus lightning. Whoa! Regular lightning happens during a storm when ice crystals bump into each other. In a dirty thunderstorm, bits of volcanic ash collide, create friction, and spark up the sky. In the hottest and one of the driest places on Earth, Africa's Danakil Desert, temperatures often rise above 120 degrees Fahrenheit. The out-of-this-world landscape has many active volcanoes and geysers that spit out toxic gases like chlorine and sulfur. The vibrantly green, electric blue, and yellow waters are all rain and seawater warmed up by magma. One wrong step here, and you'd be gone for good. This happened in June 2009. People in certain areas in Japan left their homes after a heavy downpour, only to find fish frogs and tadpoles everywhere. Fields, roads, lawns, and rooftops were littered with these aquatic creatures. One man was shocked to see 13 carp on and around his truck. Apparently, he stopped to count them. No one knows for sure where the bizarre rain came from, but the most popular theory claims that a powerful water spout picked up all these creatures. Then it carried them through the upper atmosphere and dropped the animals on the unsuspecting people below. And now, welcome to Abraham Lake in Canada. It's completely frozen. You step onto the transparent ice and look down at what lies beneath. No fish, just some mysterious frozen bubbles. They look like small clouds frozen in ice, or jellyfish who forgot to pack a winter jacket. There are thousands of these little bubbles made up of methane. But don't try to dig a hole in the ice to touch it. Methane is highly flammable. It's created by methane-producing bacteria that eats leaves, grass, insects, or any other organic stuff that gets into the lake. When the methane touches the frozen water, it turns into tens of thousands of frozen little balls. When the ice melts, they burst open and sizzle. Similar lakes can be found near some shores of the Arctic Ocean. There, the size of the bubbles can reach several times the size of hot air balloons. Beautiful for sure, but not exactly safe. The next shocking lake is in Indonesia, the island of Java. You come to a majestic volcano, overgrown with grass and trees. The volcano seems to be asleep, but smoke is pouring out of it. You climb to the summit. Exhausted, tired, sweaty, you're ready to cool off. Nice work, you made it to the top. You look into the mouth of the volcano. No boiling lava, just a beautiful, bright, turquoise lake down there. It looks like an oasis. Perfect time for a refreshing dip. You run down and get ready to jump in. But that's not water, that's acid! Sulfurous gases get into the lake from under the volcano. The lake itself is full of metals. When the gases touch them, they form that beautiful turquoise water. Acid. Better head back to the nearest village, rest, and come back at night when it's cooler. In the dark, the lake seems to glow. Right above it, you see light-filled, exploding little clouds. The sulfurous gases rise out of the lake, combine with the air, and flash bright blue. Still, don't get too close. The sea turns sinister red, and no living being can survive in it. Must be some dark magic. In fact, it's tiny algae that spread uncontrollably, giving the water this specific tint called the red tide. They have toxins that destroy sea mammals, birds, and turtles, as well as creatures that feed on them. For humans, contact with it ends in breathing problems or seafood poisoning. Sometimes even huge ships sink in the open seas for no visible reason. That reason is often the pockets of bubbles that underwater volcanoes produce even while they're sleeping. Those productive magma factories are hidden under 8,500 feet of water. When they wake up, they act just like land volcanoes, and they can cause destructive tsunamis. This tree looks like a bottle. No wonder it's called the bottle tree. It grows in Namibia and attracts many tourists. But don't get too close to the tree because it's one of the most dangerous on Earth. Milky juice flows inside the trunk. It's highly toxic to the human body. On the bright side though, the trees have beautiful pink-white leaves with a red core. There's a tree growing in Western Australia that was once used as a prison. A cell for criminals existed inside the Boab prison tree for a long time. People were usually kept there temporarily, just for one night. After that, they were taken to their final destination. The prison was built more than 1,500 years ago and has been perfectly preserved to this day. Tourists visiting this place can sneak a peek inside.
Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long, long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal. But you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface, until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tahoe you already know about, Japan's Ericaldra, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm. Or at least, we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60 but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. Ah, Kiev. You've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast! In June 2020, what the people of Kiev were looking at was an anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. people witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mauna Loa, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sundogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moondogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water. Hey, ever heard of a fire rainbow? Yeah, me neither. How about a circumhorizontal arc? Didn't think so, but just so you know, they're one and the same thing. At first glance, it looks like a painting, or like a rainbow-colored splash in the sky. Despite the name, they have nothing in common with either fire or rain. This phenomenon happens on rare occasions when the sun shines through a particular type of ice cloud formation. The rainbow halos are just as unique. Again, a specific type of ice crystals in clouds needs to be present for the surface of the Earth to bend light from the sun into a perfect ring. The same thing can happen with moonlight. The only difference will be that moon halos are usually white and sun halos can be rainbow-colored. When visiting regions with high altitudes, you may be one of the lucky people to stumble upon penitentes. They're basically naturally formed ice spikes. For them to be formed, they need a really cold and elevated environment where the air is dry. The sunlight turns ice directly into vapor rather than melting it into water. And that's why these blades of snow and ice start to pop up on the surface of the Earth. As cute as they may be, they can end up as tall as 15 feet. Now, what happens when small individual droplets of lava meet the wind? Pele's hair, basically. Let me explain. The word Pele comes from an ancient Hawaiian symbol for volcanoes. Whenever the wind picks up little drops of lava, it stretches them into hair-like strands, similar to the process of glass wire creation. These delicate strands can stretch as far as 6 feet. On rare occasions, it can rain without any clouds. But does it really? Let's look at the science behind this rare phenomenon. It's sometimes called a sun shower, just because it looks like the rain is falling straight from the sun. Let's be clear though, there is no way rain can ever come down directly from a star. Rain clouds are at a bit of a distance from that specific location. With sun rays being angled, the clouds become out of sight. Add a little wind to blow the rain in your direction and ta-da! You get sun showers. Located in Bolivia, is a place called Salar de Uyuni. It's the largest salt flat in the world. It's also the home of half of the world's lithium, which is a crucial component for making batteries. But what else is so special about this place? Well, whenever the rain season comes, it turns this piece of flat land into a perfectly reflective mirror lake. What comes to your mind when you hear about the Blood Falls? A horror movie? Well, they are merely a series of waterfalls located in one of the driest regions of Antarctica. They emerge from an underground lake filled with a special kind of bacteria. These little organisms use sulfates as fuel instead of sugars, which makes them very intriguing for scientists. The water contained in this lake is so full of iron that it basically just rusts when it meets the air. Hence, the reddish color of the waterfall, which also gives it its trademark name. Okay, we all know the song, but it's not really made up. There is actually such a thing called a desert rose. It's not a plant though, but a unique form of the mineral gypsum. It develops in dry sandy places that can occasionally flood. This constant switching between a wet and dry environment lets the gypsum crystals emerge between grains of sand, trapping them and forming a rose-like shape. Ever heard of the Eye of Sahara? Scientists are still trying to figure out how it was formed. You can only see it if you fly above it, but it's basically a naturally formed dome that dates back to approximately 100 million years ago. And no, I wasn't around then. It has a rough diameter of 25 miles and consists of a bunch of concentric rings. The biggest one, or the central area, measures about 19 miles in diameter. Astronauts were some of the first people to notice it, and it's been studied ever since. In fact, even to this day, when landing in Florida, they know they're almost home when they see the Eye of Sahara. One of the most beautifully colored trees in the world is located in the Philippines and Indonesia. It's called the rainbow eucalyptus. It got its name because of its bark that switches colors and peels away as the tree ages. The bright green bark is the youngest, as it contains a substance called chlorophyll, usually found in leaves. It then switches to purple and then to the color red. And finally, it turns brown as it grows and loses the chlorophyll. Now, don't be tricked into thinking that's a whole forest. It's one single tree. And no, it's not some sort of optical illusion either. Let me explain. Underneath that soil, there is a complex network of roots that connects around 47,000 tree-like shapes you see above the ground. It's called the quaking aspen. Some of these trees are among the oldest and largest organisms in the world. Now, here's a good destination for all travelers, or maybe not so good after all. The most lightning-stricken area in the world, according to recent data released by NASA, is Lake Maracaibo in Venezuela. Out of all the days in a year, 300 of them feature thunderstorms in this location. What makes this area so unique, though, that storms happen so often? Well, it's because where cool mountain air meets the warm, moist breeze and generates electricity over the lake. The Eternal Flame Falls are located in upstate New York, near the Canadian border. In this region, there is a tiny waterfall with a big secret, a spark about 8 inches tall. Turns out there's a natural gas seep that provides fuel to the flame behind the waterfall. The waterfall provides enough coverage so that it stays lit pretty much every time. Hikers do enjoy to relight it if they see that it's been blown out. This phenomenon is actually quite common, but this one gained more popularity because it is younger than most. And it looks very good in pictures, let's be honest. I've heard of yellow sand, white sand, and even black sand here or there. But I've never heard of green beaches until now. Papacolia, also known as Green Sand Beach, is located in Hawaii and is one of the few beaches in the world that features green sand. The unique coloring comes from olivine rock that was formed when a nearby volcano erupted. Actually, in Hawaii, all the volcanoes are nearby. Move over green sands because some of the other beaches around the world can even glow at night, and it's completely natural. The culprit? A little thing called photoplankton, or microalgae as they're sometimes called. They're basically little plants that contain chlorophyll and need sunlight in order to live and grow. Most photoplankton kinds are able to float in the upper part of the ocean, where the sunlight can still reach them beneath the water. When the photoplankton gets agitated by the movement of waves and currents, they emit light, which looks like some glow during the night. These special microorganisms are found on beaches in a lot of places around the world, such as the Maldives, Puerto Rico, and the Everglades. At the base of a mountain located just outside of Afton, Wyoming, is a little river called the Intermittent Spring. There are only 3 of this kind in the whole world, but what makes this little string of water so mysterious? Well, the fact that it starts and stops every few minutes. Scientists have yet to pinpoint precisely why this happens. They speculate that it's basically just a siphon effect that happens deep within the ground that causes the river to just start and stop so often. Should you ever be interested in checking it out, be sure to do so in the late summer, as that's when the intermittent spring is most active. Do you see the irony here? You can only see the spring in the summer? Okay, I'm done. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. So the Sahara Desert is so big that it covers 8% of the world's territory. It's bigger than the USA or China. Surprisingly, the Sahara is not the largest desert in the world. It is the third largest, behind Antarctica and the Arctic. But it is definitely the hottest one. Temperatures there reach 136 degrees Fahrenheit. This place has some of the most incredible sand dunes you've ever seen, towering up to 1,476 feet. But here's the kicker. There's a real risk that these dunes might continue to spread until they cover the entire world. Surprisingly, the influence of the Sahara Desert extends far beyond its borders. Its dust, carried by powerful winds, makes its way to the UK and across the European continent, particularly in winter. This dust, settling on the ground where it rains, is a familiar sight to those in the UK, often leaving a red residue on cars. This connection between the Sahara, England, and Europe serves as a stark reminder of the global reach of environmental phenomena. You might think this is not a big deal, but it could turn Europe into a desert, leaving its soil infertile and Europeans with no food. Soil is a fundamental aspect of human existence, just as crucial as clean water and air. Without it, we're left with nothing but a bleak and barren landscape. The Sahara Desert has already made its jump across the Mediterranean Sea, which is concerning and could change the landscape forever. 1/5 of Spain has already turned into a desert. The next victim is Italy, which also faces the problem of desertification. In fact, almost all European countries have the same issue. According to an expert, the land that has not changed for nearly 2,000 years will become mostly rock, and people living on this land will be gone. 60% of the soil in Moldova is gone, and the problem has expanded beyond the Black Sea. It has reached China and Mongolia, thousands of miles away from the Sahara Desert. All of this causes losses of $4 billion a year. The threat is so significant that even the UN has gathered the necessary resources to solve the problem as soon as possible. Italy is sending help to Africa to stop the Sahara Desert from expanding. If this process does not stop in the next 10 years, millions will be forced to leave their homes. The Sahara Desert is growing for approximately 30 miles per decade. You do the math and see how long it will take to cover Europe. Since 1920, the Sahara has expanded by around 10%. But not all hope is lost because more than 172 countries have joined to put a stop to the desertification of the world. The World Food Program is a project that aims to help bring back green land that was once present in the Sahara. When they told people who called the Sahara home what they were about to do, the latter basically laughed in their faces and said it was impossible. But when you have a specific goal in mind, the impossible becomes possible. If we traveled back around 5,000 years into the past, we would see a beautiful forest with lush green trees and grass. Africa's climate has been changing for 21,000 years, from fantastic greenery to uninhabitable deserts. This has to do with Earth's rotation and the monsoons that bring water to this dry continent. But with the help of scientists and some clever tricks, we can bring the greenery back and stop the Sahara in its tracks. The Senegal River serves as a border between the Sahara Desert, Senegal City, and Mauritania. When you look at this area from space, you'll see how the desert is expanding to Senegal because the vegetation along the riverbank is almost non-existent. Forests can serve as a barrier, stopping the sand from getting blown away and the desert from expanding. An effort to create a great green wall is being made, and how they do it is actually quite impressive. Nothing has been growing in the currently restored area for more than 40 years, making locals find other places to call home. People were thrilled when they saw that the land could be restored. They're very committed and learn to work with the soil and grow food. At the same moment, more than 30,000 hectares have been restored and transformed into lush greenery. The Sahel region is the starting point of desertification, and it is crucial to establish a green wall in that area first. To make this wall is not rocket science, since it only takes a few simple steps. The ground there is baked by the sun and as hard as a block of concrete. If you've ever poured water on concrete, you know that it just flows away. It doesn't stay in one place. So they had to create water-retaining half-moons that would hold the water and make it available to plants. When you learn about how these half-moons work, you might say, how did they not think of that sooner? Actually, this technique is ancient, and it was once implemented in Sahel, but it was lost over time. When the rain falls, the water is collected into the half-moons that are positioned a bit lower than the ground below contour lines. There is also a kind of bank at the end of the shape that prevents water from overflowing. And in the middle, there are plants that are happy because they have plenty of water to thrive. Also, it's essential to grow native plants that are kind of used to harsh conditions, like sorghum and millet. These plants have been surviving there for thousands of years and produce a good amount of biomass, which means the land can be rehabilitated faster and people will have food sooner. The water that will enter the half-moons won't be lost. It will penetrate the ground and top off underground waters. This will ensure the ground that H2O will never run out and that future generations will have usable aqua. This brilliant planting technique is not limited to half-moons. People also create lines and plant various vegetables, such as tomatoes. Next, there are places only for trees, like lemons or oranges. After a long hot day, nothing is better than a freshly made cold lemonade. The trees will also protect the soil, and with some luck, there will be a new forest in the Sahara Desert. The goal is to copy the forest dynamic. Start with small plants and gradually expand to bigger plants that are more useful than the tiny ones. They are aiming to plant more than 10,000 trees. Right now, many people are leaving the Sahara after the rainy season, going to cities or leaving Africa altogether. At this time of year, villages are like ghost towns. Only animals can be found there. Most people are gone. I mean, who would blame them? Nobody wants to live in the sand where nothing grows. Luckily, with all this new, old technology being developed, many people are slowly but surely returning to their land and starting to work in agriculture. The best thing is that there are no brutal winters, so plants grow 12 months a year, and people can always have food. People are becoming more social because now everybody stays in their villages and doesn't travel much. If this project works out, Africa will be saved and the world won't turn into a giant desert.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference. but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes. We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Nina also brings warmer winters to the southern U.S. and cooler than normal temperatures to the north. La Nina usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the U.S. But this year, we've switched to La Nina, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the U.S. wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside. Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington Event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington Event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Ah, a purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the Earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide, that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the US around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis, but there's something that can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly, the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town, block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, uh-oh, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Asteroid. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Dropner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of 3 large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. Due to such a long isolation, the conditions inside the mobile cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide. So not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say, thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. Filling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
Did you know there's a guy who rode on a wave for 7.5 miles? It was accomplished by Brazilian surfer Picaruta Salazar in 2004. Just for comparison, Central Park in New York extends for a mere 2.5 miles. That was the Pororoca wave, and it can only be surfed for 3 days a year. It's pretty powerful, so it sort of pushes you. But there are definitely some tough spots where it's not that easy to catch waves. If you're looking for the gnarliest surf spot, Pipeline in Hawaii is where it's at. But beware, it's not for the faint of heart. This place is known for its massive waves that can reach up to 20 feet tall. And did we mention the shallow reef? Yeah, wipeouts here can result in some serious injuries, or worse, you might end up sleeping with a fish. The waves at Pipeline are also super unpredictable, so you never know what you're going to get. It's like a box of chocolates, except instead of chocolate, it's huge waves that could crush you like a bug. But hey, if you're feeling brave, the annual Billabong Pipe Masters competition is held there every winter. Just make sure to bring your A game and a change of underwear. Even the most experienced surfers approach Pipeline with caution and respect. It's like trying to tame a wild animal. One wrong move and you're toast, or dinner. So if you're ready to ride the gnarliest waves in the world, come on down to Pipeline. Just don't say we didn't warn you. For those who are dreaming California, there's a tough spot in the Golden State for you. Mavericks is notorious for its massive swells and strong currents, making it a challenge even for experienced surfers. Hold on tight, because this wave is gonna take you for a ride. First off, let's get one thing straight. Mavericks ain't for the weak. This bad boy can reach heights of up to 60 feet. But hey, if you're a seasoned surfer and you're feeling brave, then Mavericks is the place to be. Located just off the coast of Half Moon Bay, this spot is known for its massive swells and killer waves. It's like the Hulk of surf spots, big, bold, and ready to smash. Now, don't go thinking that Mavericks is all about the waves. Oh no, my friend. This spot is also home to some of the coolest surfers around. These dudes and dudettes live for the rush of catching a maverick wave, and they'll do whatever it takes to get out there. But here's the thing, Mavericks isn't just about surfing. It's also about community. These surfers have each other's backs, and they know that when they're out there on those massive waves, they're all in it together. It's like a big, salty family. So there you have it, folks, Mavericks, the wildest, most insane surf spot in California. If you're up for the challenge, grab your board and head on out. Just remember, when you're staring down a 60-foot wall of water, it's okay to scream like a little girl. We won't judge. Broken skulls. The waves at Chupo are massive and can reach up to 23 feet high and break over a shallow reef, which creates a super powerful wave that can barrel for hundreds of yards. And if you wipe out, well, let's just say you'll be getting up close and personal with that reef. It's like a cheese grater for your skin. So make sure you bring some Band-Aids and a good insurance policy. But hey, if you're up for the challenge, Chupo is one of the most epic surf spots in the world. However, I hope you're going to choose a much safer spot. If you're looking for some cool waves but don't want to risk your life, then you gotta check out these safe surfing spots around the world. First up, we got Waikiki Beach in Hawaii. This spot is perfect for beginners and pros alike, with consistent waves and a sandy bottom. Plus, there are lifeguards on duty to keep an eye out for any trouble. Next, there's Bondi Beach in Australia. This iconic beach is known for its beautiful scenery and chill vibes, but it also has some great waves for surfing. The water is shallow, and there are plenty of surf schools around to teach you the ropes, or in this case, the boards. But if you're looking for something a little more exotic, head over to Nocera in Costa Rica. This spot has warm water, consistent waves, and a laid-back atmosphere. Plus, the locals are super friendly and will welcome you with open arms. Last but not least, there's Muizenberg Beach in South Africa. This spot has some of the most consistent waves in the world, but they're not too big or dangerous. Plus, there are shark spotters on duty to keep you safe from any unwanted attention from local carnivores. But no matter how safe the spot is, you're still going to need some cool life hacks to bring your surfing to a brand new level. Have you ever wondered why surfers use wax on their boards? Well, let me tell you, it's not just for show. See, when you're out there shredding the gnar, you don't want to slip and slide all over the place like a penguin on ice. That's where the wax comes in. Basically, the wax creates a grip on the board so you can stick to it like peanut butter on bread. Without it, but here's the thing, not all wax is created equal. You gotta find the right kind for your board and the water conditions. It's like choosing the right flavor of ice cream for your cone. You don't want to end up with mint chocolate chip when you really wanted Rocky Road. So, next time you see a surfer waxing up their board, just remember they're not doing it for the smell, although some waxes do smell pretty sweet. They're doing it so they don't wipe out and embarrass themselves in front of all the folks on the beach. And that's worth its weight in gold. And by the way, did you know that rubbing a little bit of wax on the bottom of your feet can give you a better grip on your board? Yeah, it's like magic. No more slipping and sliding around like a seal on a wet rock. Another common hack is to wear earplugs. You see, there's even a condition called surfer's ear. Surfers are constantly exposed to cold wind and water, and some of them even surf in cold temperatures. If your ears are constantly exposed to cold, your ear canal may shrivel up. As a consequence, water, wax, you, and even air all get trapped in your ear, which may lead to certain infections. So, to prevent water and cold air from getting trapped in their ears, pro surfers like to use earplugs. But even if you're just a newbie, you gotta use their tip. Oh, and here's another classic. If you're surfing in cold water and don't have a wetsuit hood, just rub some petroleum jelly on your ears to keep them warm. Hey, why do you think some surfers have clear nail polish on their emergency kits? It's not for their nails, but for their boards. So, if you're dealing with a stubborn ding in your board, grab some clear nail polish and fill in the crack. It'll keep water from seeping in and causing more damage. However, pros will say that nail polish is a terrible idea, and there are a lot of repair kits out there. Yeah, this one's up to you. So, there you have it, my fellow wave riders. Now go out there and shred those gnarly waves like the pro you are.
A tsunami can travel unnoticed in the deep waters at the speed of 500 miles per hour, crossing an ocean in less than a day. When it approaches land, a tsunami will slow to about 20 miles an hour and begin to grow in height. Most of these waves are less than 10 feet high when they hit land, but they can reach more than 100 feet high, about 2 times as tall as the Hollywood sign. When a tsunami comes ashore, areas less than 25 feet above sea level and within a mile of the sea are in the greatest danger. But sometimes, tsunamis can go 10 miles inland. If you're by the coast and feel a strong earthquake, especially one that lasts for more than 20 seconds, that could be a major red flag that a tsunami is on the way. Keep an eye out for sudden changes in the sea level. If the water suddenly recedes way further back than usual, exposing normally submerged areas, that's a sign that a tsunami might be on its way. Plus, if you hear a roaring sound coming from the ocean, like a freight train or a jet engine, that's another ominous sign. And pay attention to any unusual animal behavior. Animals have been known to sense danger before humans did, so if you see birds or marine life acting strangely, it's time to take notice. If you receive an official tsunami warning from authorities, whether through sirens, radio, TV, or mobile alerts, don't ignore it. Take immediate action. If you're in a tsunami-prone zone and experience an earthquake, don't even wait for official warnings. As soon as it's safe to move after the shaking stops, head to the nearest elevated area promptly to ensure your safety. Practice evacuation routes before a real disaster. You might have to follow this route at night and in terrible weather. If you know it well, you'll need to do less thinking in an emergency, which can be life-saving. Talk about tsunamis with all your family members. Everyone should know what to do to minimize fear and win some precious time. Don't store your important papers and valuables in low-lying areas. Floodwaters can go really high during a tsunami, so put your documents in waterproof containers on higher ground. After an earthquake, bridges and roads often get damaged or become blocked. Not to get trapped in a car in a potentially hazardous location, walk or run towards safety. Never go down to the shore to watch for a tsunami. If you can see the wave, it means you're too close to outrun it. Most tsunami-prone areas have signs indicating evacuation routes. Look out for white and blue signs marked Tsunami Evacuation Route, or similar instructions to guide you inland and away from danger zones. In urgent situations where evacuation isn't possible, seek refuge on the 3rd floor or higher in a sturdy building. Even better, aim to reach the rooftop of the tallest and most robust structure nearby. It's better than being exposed. A tsunami is not a single wave, but a series of waves with massive amounts of water that can flood for hours. The first wave may not even be the largest. So, remain on high ground, away from the coast until you receive an all clear from the authorities. You're really unlikely to survive a tsunami in a basement below ground level. As it passes over, everything in its wake gets submerged temporarily until the water recedes back to the sea. If you're in a basement during a tsunami, you might get crushed by collapsing buildings or swirling debris. Unless the basement is exceptionally sturdy, waterproof, and equipped with sufficient air supply, it's not a safe option for shelter. If you happen to be out at sea when a tsunami warning is issued for your area, stay put and avoid returning to port immediately. Tsunamis can sneak up on you with rapid water level changes and dangerous currents in harbors and ports, making them unsafe. In large harbors and ports, authorities take charge during tsunami alerts and direct vessel movements for safety. It's important to stay in touch with these authorities and follow any instructions they give regarding moving your vessel. For smaller ports without such organized control, it's a better idea to carefully relocate your boat to deeper waters. If you have a small boat, the best you can do is leave your vessel at the pier and seek higher ground yourself. If a tsunami gets you in the water, find something sturdy like a tree, a door, or a life raft. Grab onto it tightly while you get carried by the waves. Try your best not to swallow any of the water. Tsunamis can pick up chemicals and waste, which won't do you any good. People in life jackets have a higher chance of survival because they will remain on the surface of tsunami waves and can breathe normally. Tsunami waves aren't like ordinary waves, so they aren't suitable for surfing. Tsunamis don't have a face to ride. They're more similar to tides as they rush in and out. They're much larger, faster, and more powerful. So, trying to surf them is not only dangerous but also illegal in many countries. Because tsunamis come from underwater disturbances, like earthquakes, they're even dangerous for submarines. Despite submarines' robust design to withstand underwater pressure, the force of tsunamis can cause damage. Tsunamis also generate strong currents that can mess up a submarine's ability to navigate effectively. In cases of severe tsunamis, submarines may get hull damage, threatening their buoyancy and integrity. Such scenarios can lead to submarines sinking or being carried away by the waves. That's why submarines operating in tsunami-prone areas must be extra careful and equipped to respond swiftly if this sea monster strikes. Scientists still can't predict tsunamis, but they can use their expertise in seismology and historical tsunami data to identify earthquakes likely to trigger tsunamis and issue warnings. They gather crucial data from seismic and water level networks worldwide, which enables them to swiftly assess earthquake characteristics such as magnitude, location, and depth. Utilizing this information, they determine whether an earthquake has the potential to generate a tsunami and decide on issuing tsunami advisories. For regions like the US and Canada, warning center scientists can typically issue preliminary messages within 5 minutes of an earthquake. These messages include alert levels, earthquake details, threat evaluations, anticipated wave arrival times, recommended actions, and potential impacts. On the 26th of December 2004, early in the morning, an enormous earthquake shook up the ocean floor near the Indonesian island of Sumatra. This seismic event unleashed a monstrous series of waves, tsunamis, that spread out across the Indian Ocean, reaching as far as East Africa over the next 7 hours. These waves were towering walls of water, some reaching a height of over 30 feet. When they slammed into the coastlines of countries like Indonesia, Sri Lanka, India, Maldives, and Thailand, the devastation was catastrophic. Over 200,000 people lost their lives in this most devastating tsunami on record. And it wasn't just the immediate impact. Long-term consequences hit hard too. Villages, resorts, farmlands, and fishing areas were destroyed or submerged in salt water along with debris. Japan is one of the most earthquake-prone countries in the world because it's located on top of 4 converging tectonic plates that constantly interact with each other. After a terrible tsunami in 2011, the country started a colossal project dubbed the Great Wall of Japan. With a jaw-dropping price tag of around $13 billion, this wall goes from the north to the south of the country. The goal is to safeguard coastal towns from future tsunamis, buying its people precious time to save themselves. Some locals worry that this towering structure will sever their deep-rooted ties with the sea. They fear losing touch with the ocean's rhythms and cues, which are crucial for spotting upcoming disasters. But for many coastal towns, the wall is a lifeline, giving them hope for rebuilding shattered lives post-disaster. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish, okay, this one kinda looks normal until you raise it to the surface, the goblin shark, Sloane's viperfish, zombie worms. Ugh, yeah, I hear ya. Let's move on. The seafloor hides things from space, too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn!
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount, so all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about oceans past. Ancient mollusks could live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes, like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, These conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe,